Hello guys, welcome back to our YouTube channel. In today's video, I'll be taking you guys through graphing of our trigonometric functions. So in the past videos, we have throughout trigonometry 1 and trigonometry 2, we have talked about the sine and cosine functions, and then in these videos, I'm going to take you guys through how to graph these functions. Okay, we need to be able to see how they look like so that we can understand our analysis. So the first function that we'll be looking at today is the sine function. And then, so let's imagine we have a particle at this point, which is moving in this direction along with the circle, like around the origin, right? So when this particle reach, let's say this point, the particle there can be described at this point can be described by what? Some angle. Okay, the position of the particle can be described by an angle. When a particle reaches this point, it will be described by what? An angle. It is 45, right? When it reaches this side, it's what? 90. So we can take those angles and convert them to what? Distances. So that's what we'll be using to draw what? The function. Okay. And then the relation that links them is that what? The distance is equal to the sine of what? The angle. So the angle that you have over here, you just put it into this and then you get the position of that particle along that circle. Okay. So when the particle is now moving along this side, you realize that this is what the relation you get. So let's do something. So when the particle was at 0, sine 0 will be 0. So that corresponds to what? This side, right? When the particle is at pi over what? 2, that's 90. Sine 90 is 1, so that corresponds to the top part here. And when the particle reaches this side, sine 180 is what? 0, so that corresponds to what? The 0 side over here. And when the particle reaches what? 270, sine 270 is what? -1, and that corresponds to what? This side. And then the particle returns back to what? 360, which is 0, which is what? This side. So that's a complete cycle of what? The sine function. And the things that happen after this place will be the same repetition of this side. And that's what we'll talk about as what? Periodicity. Yeah, so a sine function has what? A periodicity of what? 2 pi. So what that means is that, so let's just say we are starting from here 0, right? From 0 to 2 pi. That is what? The full circle of what? A sine function. The full circle of a sine function. The idea of periodicity is what you are looking for is that, so after what angle is the same thing happening like it happened before. So we move that from 0 to what? 2 pi. That's a full circle. After the domain of a sine function includes what? Let me go back and we'll do some few steps. So you realize that from 0 function varies across. So you should take note of that. That's why we say that the cons function. So the same scenario, we have a particle moving along the edge 180 degrees. That's -1. The minimum value decreases to what? Some point 2. So the periodicity of cosine function is also 2 pi. This one, and what that means is that what? So like the sine, after from you see from negative from 1 here to what? To 2 pi, what we have here will be the same thing that will repeat itself for the angles that are increasing in this direction and for the angles that are in this direction. So you can see that when you move here from here to -2 pi, you see the same complete circle, right? So that's the periodicity. So the periodicity of what? Sine, the cosine function is also what? 2 pi. And then we need to talk about the domain. So the domain will be all hot real numbers, like real numbers. So from -infinity to +infinity, right? So that's the domain. And then the range is from -1 to what? From -1 to 1 inclusive. So that's the range. And then so it's cos function Cos function is what? An even function, right? So and then it is symmetric about what? The y-axis. And also remember that the sine function was what? Symmetric about what? The x-axis, right? The sine function was symmetric about what? The origin, yeah, the origin, not the x-axis. But then the cos function is what? Symmetric about the y-axis. So you should take note of that. And it's an even function. Now let's move to the tan function. So we know that tan is equal to what? Sine over what? Cos, right? So for this to be undefined, the bottom part cos theta should be equal to what? 0, right? Cos theta should be equal to 0 to make it undefined. And the values that make cos theta to be 0 are what? Odd multiples of what? Pi over 2. Odd multiples of pi over 2. So that's negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, continuous, like infinite. So we need to remove all those values from what? The set, right? And then so when you take the range from negative pi on 2 to pi over 2, and then you compute the various angles you get over there, so you realize that for when the angle is what? Negative pi over 2, tan is what? Negative infinity, right? And when it is pi over 2, it is positive infinity. What that means is that when you are drawing the graph, at this point, the function what? Does not what? Exist. So the graph will not touch these values. The graph will not touch those specific values. The graph will not touch those values. So when you draw it, you see that at negative what? Pi over 2, the graph is what? Asymptotic to what? This axis. And then the same thing is applying for what? Positive pi over 2, and then the odd multiples, right? The odd multiples. So here you can realize that the same thing is repeating itself after what? A period of pi, right? So from here to here is pi. From here to here is pi. And that's what we talk about as what? The periodicity. So it's repeating itself after what? A pi radian, right? And also note that what? The graph here will never touch this axis. That's why it's considered as what? A vertical asymptote. The domain are all real numbers except theta is equal to what? Odd multiples of what? Pi over 2. Okay. And then the range is all real numbers. The range is every number. So we can see that for the sine function and the cos function, the range is just from negative to what? Positive, right? But then for this one, the range is very long. Okay, you can see you have negative 5, and then you can continue, right? So long as the function doesn't touch what? The axis, it can continue. That's why it's negative infinity to positive infinity. And then tan function is what? Tan function is an odd function, and then it is also symmetric about what? The origin.